Hello, class. To show you how important chemistry is, I wanted to talk to you about how chemistry is helping athletes in the Winter Olympics and also affects how they run the Winter Olympics. So, of course, at a very high level, right? So, like the Olympics, these are amazingly trained athletes, and they have expensive suits and expensive gear. And this article in part goes over some of what scientists and engineers have done to help these athletes to get a very, very little bit of an edge. I have this open on a web page. I know I normally talk to a PDF, and the PDF doesn't translate as well for this article, and especially when I get to the section talking about skis, that graphic doesn't translate as well. So, but you can see this is I have the web page open. It has, of course, the skiers here and the snowfall going. So, first of all, with material science, it talks about the suits that people wear. So, like for the speed skating, they have various materials, and they've taken them and placed them into wind tunnels, and they look to change the drag and how you can get slight advantages over others using these materials. So, and of course, this is material science, and which is interesting with this article. Everything is really a physical property rather than a chemical property, and this certainly goes with the drag involved in these speed suits. And also for skiing, here's the graphic that doesn't translate as well. Shows the layers of skis. I mean, when I go skiing, I usually just rent my skis, and it's just kind of a metal ski. I don't. It talks about wax. I never put wax on the skis either. I just kind of got the skis and the poles and jumped on down the hill after I took a ride up, right? But these have the Olympic skis, and for the very expensive ones, they have various layers. Of importance here is this base, the ultra high molecular weight polyethylene. So poly means many, and ethylene, it's just it's basically a very big alkane. So what's an alkane? It is a hydrocarbon, so it has only hydrogen and carbon. It's all single bonded, and the alkanes are also referred to as paraffins, and paraffins are very unreactive. So you heard of paraffin wax candles, for instance, and in this article, also, this is the first Olympics that they've banned fluorinated waxes. So when you put fluorine on alkanes, or substitute fluorine for hydrogen on the alkanes, it tends to make things very slippery. Teflon, for instance, is an example of that. So Teflon is very slippery, has very little friction. And the idea is to limit the amount of friction that the skis have. And now they've banned it for these Olympics. And some people are upset, and what are they looking to do? And there's something, if you read this, you can see that not everyone is in agreement, and maybe there is a difference, maybe there's not. I don't know. I've never really gone through this deep dive into skiing. But maybe on the molecular level, a little bit of paraffin does make a difference. So, but I mean, at the same time, the surface of the ski is an alkane. That's the high density. It's the ultra high density polyethylene. So, it's really the same thing, but maybe there is a small difference in the coefficient of friction. Who knows? So, but the author, one of the authors of the article, argue that just use paraffin wax. It should do the same thing, especially with the way that the ski is built. So that's interesting. It's also great. It's better for the environment, so you don't get the fluorinated hydrocarbons into the environment. Also, material science talks about the boots that are used for these ultra marathon events. I think that's interesting as well. This is the last piece. Is what I found really interesting, is that they have different types of ice for different events. I just thought ice was just frozen water. They just took tap water and froze it. But I guess different events require different things. So for curling, for instance, The curling, they really need very pure, so 0 to 10 parts per million total dissolved solid. So what's a dissolved solid? Salt, sodium chloride salt, for instance, is a dissolved solid. So it dissolves in the water. But figure skating, you need to have it's a little bit more, so 120, 150 parts per million for softer ice. So that adding the salts to the ice makes it softer, and so that when these people are doing their acrobatics, that there's a little bit of give, and then speed skating, hockey, or somewhere in between. So we have certain events that require really hard ice, which is the curling, and then you need softer ice for the figure skating, and then you need to have somewhere in between for other events. So I hope you enjoy it. I thought this was it. Sorry. Well, I hope you find the article interesting, and hope it makes you think of how science can affect your life in other ways, and also with all my articles and my videos with you. I hope it finds you very well. If you are not doing well, if you need anything, if you're lacking basic needs, if you're dealing with some mental health crises, dealing with other academic issues, or anything else you need help with, please feel free to reach out. I'll do what I can to help. So, goodbye. And if you're watching the Olympics, I hope you enjoy it.